All right, everyone. Welcome to Section 4. This week we'll be talking about this Project 2, which is iOS's Evil Hangman. So here's just a list of things we'll be going over today. So this is kind of structured in a good order to proceed in the project. So getting started and then basically the various components of the project that you need to complete in order to get a working game. So the order we'll be discussing today is kind of a good order to complete your own project in. So as the spec mentions, Evil Hangman is very evil. It's a really fun game to make. So the ultimate goal of this game, as we brought up a little bit in lecture, and if you want to read the really long spec, you'll see that the goal of this algorithm, the goal of this game, is to dodge the user's guess as best as possible. So it's going to employ this strategy that the user is not going to be aware of, in which the computer is effectively allowed to switch among words. So it doesn't actually at any time choose a word that's going to be the hangman word. But it is constantly switching between sets of words depending on which set maximizes its ability to cheat and therefore maximizes its chances of winning. So let's just look at an example. So you'll be implementing two algorithms. So the first, the good algorithm, is just standard hangman, and it's a little less interesting than this. And so this is the evil algorithm in which the computer is allowed to cheat. So what is fixed at the start of the game is the length of the word. And the spec mentions that this is something that the user can adjust based on the settings panel on the other side of your app. So let's just say we have a game in which we've decided at the beginning that there are 3 letters in the word. So just like normal hangman works, we have 3 blanks. So rather than consider the 200,000 words that will not fit on the slide, we'll just restrict ourselves to this set of words here, all of which are 3 letters. So let's say that I'm the user, and I first guessed the letter N. So at the start of this game, I have every word possible still remaining. Like, as a computer, I can switch among any of these words. So now, once the user guesses the word N, I have a few things I can do. So if I tell the user there is no N in this word, well, out of all of my possible words here, only one of them does not have an N anywhere. And that's the word LOL. So now if I were to say to the user, there's no N, that means I'd restrict myself to this set of one word, which is probably not the best strategy. So if the user guesses an N, so now I have 2 choices. I can say there's an N at the beginning of the word as the first letter, in which case I'm left with these 3 words here. Or I can say there's an N at the end of the word, in which case I'm again left with 3 possible words. So in this case, we have a tie, right? I could tell the user either one of these last 2 choices, and my chances of being able to cheat, the ability for me to maximize my chances of winning, are going to be exactly the same. So let's just break this tie randomly by saying that, well, I'm going to commit to saying that there is an N at the end of the word. So this is one of those cases that we mentioned in lecture that it actually is more strategic for me to give away a letter, which initially might not seem as strategic because the user now has fewer blanks to guess. But in reality, I'm actually optimizing because I have more words to choose from after I've committed to this letter. So now that I've committed to this letter, I've effectively removed a lot of words possible. Right? I can no longer say that the word is LOL or NVM because I've committed to this N being here. So I've effectively removed some words out of my set. So now let's say the user guesses a P. So now again, I have 2 choices here. I can say that there is no P in any word, in which case I have 2 blanks. And I'm going to restrict myself to the set of words without a P. So in this case, there are 2 words with no P. Or I could say to the user, there is a P in the first slot, in which case I'm going to leave myself with only 1 word left. So you notice here that I don't need to bother with saying, well, what if I tell the user there's a P in the middle? Because there are no words left in my set with a P in the middle. So that isn't really something I even consider. So now it's obvious what I should do. In this case, I have 2 words left if I commit to no P, and 1 word left if I commit to a P. So in this case, there's going to be no pseudo-randomness at all. I'm just going to say, nope, there is no P in the word. So next, if the user guesses the letter O, again, we have a 3-way tie. So broken pseudo-randomly, I perhaps could unfortunately commit to this last one, or a little backwards there, I could commit to there, and then the user guesses a W, and that's it. So is everyone clear on how the algorithm is actually working? So when you're implementing this, I would not recommend that you start with the Gigunda list of words. All right, that's just really, really complicated. And what I instead recommend you do is make your own little dictionary that contains only a much smaller set of words, much like we've done here. And we'll go over how you could even create your own dictionary as a plist file in just a bit. But once your algorithm starts working on the smaller set of words, then you could gradually build up to that huge dictionary. Because not only is that going to be a lot more corner cases, but it's also going to be a lot more processing time, which again is something we'll cover. But the best way to approach this problem is to start with the small dictionary and gradually build your way up. But do make sure you do support the full words.plist file before you declare yourself totally done. So this algorithm, in the world of computational algorithms that I'm not that good at, is called a greedy algorithm. So basically what you're doing here is you're optimizing at each step. So at every step of this algorithm, the user has presented a guess. And rather than say, well, the user guessed a Q here, and maybe next time they'll guess a U, so I'm going to take that into consideration, we're only considering their current guess. So this is not necessarily optimal, right? Because there could be a word that we know the user was never going to guess, so we should go with that. Or there could be correlations between guessing. First I guess a vowel, I might guess another vowel next. So we're not really considering that. That would be cool and would probably make our performance better, but we're not worrying about that. Instead, we're just performing this greedily. At every step, we're leaving ourselves with the most number of words left. And it turns out that this actually works pretty well, even though it might not be necessarily optimal. So everyone clear on the evil algorithm? OK. So we saw last week in lecture and in section the utility application, which has your main view controller and your flip side view controller. So we won't go through that ad nauseum. But I do have here, and that will be online, just a more annotated version where I've just left some comments to you and explained all of the template code in both inline and block comments here. But just to run through it one more time, just recall that there's this main view controller here. That's just the front. You click on that button. It's going to fire this method here that says show info. And the means by which you're actually switching between view controllers is first by instantiating your second view controller. So here I've said alloc, which allocates the memory for it. And then I'm initting it. I'm supplying the name of the nib, or that .xib file in which my user interface is defined. Right? Without this, the class doesn't know which user interface file to use. There's no way of making that association automatically. So when I say init with nib name, I'm supplying just the name of my file here without the file extension. And then this second argument here, bundle, could just be used to send some additional information, and we're not going to worry about that. And then once you've created it, you actually need to present it to the user. So to do that, you're going to use this present modal view controller method. So traditionally, we think of a modal as something that's more of a pop-up or something that fills the screen. So this isn't more of a pop-up, but as much as it is a view controller that's just going to fill up the screen. So there's basically no way of interacting with any other view controller other than the current one when I present it modally. And so that's just what this modal means, even though flipping to the other side of something isn't something you traditionally consider as a modal. So no worries, that's the function to use, even though it doesn't really look like a modal. So we saw we can flip this animated bit back and forth, can change the transition if we want. And then again, this flip side view controller is using a delegate here that we've defined here. We've created a protocol, we've assigned a delegate, and then we're using those delegate methods in the main view controller to determine when something has been done in the flip side view controller from the other side. And we'll take a look at protocols in more depth today. So we should be pretty clear on the basic template application that we'll be using. But if not, definitely refer to this for some more in-depth comments. So like you've done for Project 0 and 1, and I'm sure you've loved it, is use Git for version control. So again, we'll be relying on Git for Projects 2 and 3, even though we're moving from web to iOS, because it just really nicely facilitates collaboration. So Git is actually built into Xcode. There's some really nice functions that are built in there. So if we open up Xcode, and we go to File and come down here to Source Control, you might see some familiar verbs. So we can commit, we can push, we can pull changes from our partner, we can merge even if we wanted to. But so to set this up, I'm first going to come down here to repositories. So using here's just an example repository that I've set up. I have all of my commits here that I can very nicely browse. Now if I come over here to the left and click on remotes, you can see here all of the servers that I can push this code to. So for the case of this project, this is probably just going to be your Bitbucket server. So normally you're used to saying git push origin master, and eventually at some point you said git remote add origin and gave some Bitbucket URL. So in Xcode, it's much nicer. You can just do this from a graphical interface rather than the command line. But here, if I were to edit this, I could basically see that this is hosted on GitHub. You'll be hosted on Bitbucket. And then by setting this up through the Add Remote button here, I'll just ask you for a name and a location. You'll type in your Bitbucket URL. You'll call it Bitbucket or something. And then when you say file source control push, it's going to handle all of that for you. Any questions there? So personally, I prefer to work with Git at the command line, just because there's much more you can do with the command line than you can do in Xcode. And Xcode has a few bugs in it. As you mentioned in the PSEP, the HTTP cloning doesn't seem to work that well. But that's OK. You'll probably just end up committing and pulling anyway, which works pretty well from Xcode. So questions on that integration? Again, just be sure that if you do end up using Git from the command line, you're doing so from your Mac command line, not the appliance command line. And similarly, when you end up submitting, you don't need to open up the appliance. You'll actually be doing all of this from your Mac's terminal. So on that note, just to recap the requirements for the project, you will need to have a Mac running Lion. So that's 10.7 and up. Xcode 4.3.1 is the current version. And so that's the version we'll be standardizing on. And your Mac should come pre-installed with Git once you download Xcode. That should be just accessible at the command line. And there shouldn't be any hoops you need to jump through for that to be working. But everything is now on the Mac, not on the appliance. So the first thing you probably want to do with this project is figure out how you're going to be getting input from the user. So the spec mentions that you need to do so via a hidden text field. Or not necessarily hidden, but from a native text field. Right? We can't just have an array of buttons and allow the user to press the button A. It actually has to come from the keyboard. So the way to receive keyboard input from that system keyboard is using the UI text field, which you looked a lot at last week and saw that this UI text field delegate is a protocol that we, as a view controller, can choose to implement in order to gain access to more features of the text field and respond to different events that occur with the text field. So the spec mentions you probably don't want to show the text field because that'd be a little awkward. So let's just go over really quickly how we'll be able to get keyboard input without ever showing a text field. So if we look first at my nib here, you'll see I have two things. The first is this label up top, which is going to display the contents of my text field, so it has nothing by default. And then here I have a text field. And so this is what's actually going to be typed into. But as we said, we don't necessarily want to show that, because that's kind of an awkward UI and doesn't make sense. Really makes sense in the context of Hangman. So to hide a text field is really simple. After I connect my outlets and I connect all my actions, I can just say something like self text field hidden is yes. And that's it. There's going to be no more text field that appears on my app. But now, if the text field is hidden, we need to somehow be able to display the keyboard, right? Because if there's no text field, the user can't tap on it. That will pull up the system keyboard. So to do that, we can utilize this notion of a first responder, which you looked at a little bit last week. But the first responder in an app is the UI component that currently has focus. So when I tap on a text field, I'm giving it focus. And in the world of HTML5, that will trigger a focus event in your browser and the blur event when you're no longer in that text field. So in the iOS world, when I click on that text field and I give it focus, it is now the first responder. So if I want to give something focus rather than force the user to touch it, I can simply call this message become first responder on that element, and it's effectively going to focus it. So because I'm calling this on a text field that's hidden, what's going to happen is the keyboard is going to pop up, but the user isn't going to see what he or she is typing into. So once I'm typing, the way that I need to actually respond to types is with this method here, or key presses rather. This really nicely named method, text field should change characters in range replacement string. No need to read it because it's a lot of words. And so this is what's going to be fired when the user actually presses on a key. And where did I find this out? Well, I remembered that UI text field delegate is something that defines a bunch of methods. So if I were to click on this or just Google it, I can see a list of methods that are that I can implement as a result of using this protocol. So one of those methods is just this one here. And what it does is explain the documentation. But it's basically just fired every time the user presses a button. And what the user has typed, which key the user has pressed, is just passed into me as an argument. So I can take that argument, which is just called string, and I can take the current text of this label that's going to display what the user is typing. And if I append them together, I'm effectively implementing my own little text field. So here we just return yes by allowing the user's key press to actually register. We get an effect like this. So here we go. So you notice that my keyboard has popped up immediately. That's because I called that become first responder. I don't see any text field, but as I start typing, my key presses are going to register. You can see here that because I've kept on autocomplete, you can actually see where the text field would be. But because I've hidden it, it doesn't appear. Auto capitalization and autocorrect are both things you can disable right from Interface Builder, so that might be something you want to do too. So any questions on how that's working? So it should be pretty straightforward. You just need to implement that protocol method that says, I want this to fire every time the user types something, and then you can respond to what they typed as effectively their Hangman guess. So the dictionary is given to you as a .plist file, which is probably something you haven't encountered yet. It's very Mac-oriented, but it's basically just a special way of storing key value pairs as XML. So when I see key value pair, this is effectively a hash table or a hash map or what we used in local storage. Just some string key is mapped to either a value or a set of values. So because these are stored as XML, this could be what a simple plist value looks like. So there should be brackets around that array there, but my PDF refuses to compile if I use them. So that's why those less than and greater than signs are omitted, but they should be there. And I can basically say something like this. So I'm defining some array element, which is just something I can use in the plist specification. And that array element has two children, which are both strings. So you can see here what the plist is effectively doing is taking data types and making them XML elements. So by making strings children of array elements, I'm basically constructing an array of strings. So that's nice. So I can now have this plist file inside my application. Now when I want to use it, it's really easy to load this plist file into memory. So because a plist is just key value pairs, that very naturally lends itself to this NS dictionary thing. Because a dictionary, like a hash table, is just a set of key value pairs. So when I create an NS dictionary after calling alloc, instead of just saying init, one of those extra methods I can call is init with contents of file. And what this does will literally take some file, parse its contents for you, and put it into the dictionary. So no more XML parsing, no more parser9.php as with Project 0. It's really, really easy to load in the dictionary list of words. So similarly, you can load from a plist. It's really easy to write to a plist. You can just take a dictionary and say write to file. It will take the contents of that dictionary and just write it out into a plist that will be stored on the user's device. So how do you access where this plist is stored? Well, this NS bundle object, as we saw earlier, where you can pass in bundles, there's this nice kind of global singleton that contains information about where your app is on the device. So from the bundle, I can effectively say, where am I on the user's device, and where are the files that I'm reading and writing to stored? So with this path for resource message, I can say, I want my plist, my staff.plist that's associated with my app. I want you to find it on the user's device and give it back to me. So with this, I don't actually need to type in a full file path because all of your iOS apps are sandboxed. So this is basically a way of accessing the things that are inside of your sandbox with this NS bundle singleton. So let's take a look at how to actually do that. So here, I have a very simple plist. If I click on it, I can see the Xcode plist editor. If I were to actually open up this file, I would just see a bunch of XML here. But I've created an array, and I can add things to it by clicking this plus, remove things by clicking the minus. So here I just have an array of strings. And if I wanted to change the data type, I could. And again, that would just change the element that's actually used in the XML. So I've put this inside of my supporting files. There's actually another plist there that sets some information like the title of my app, the icon that's used, things like that. So I've just created this plist by hand. Now if I want to use it, we're going to use those combination of those two methods we just looked at. So first, I'm going to create an NS dictionary. So again, this is just a set of key value pairs. Now when I create this NS dictionary, I'm saying that I'm going to init with the contents of a file. And now what file do I want to give it? So I'm using this bundle. So it's just a singleton. I'm not instantiating it. It's already there for me, and there's only one of them inside of my application. So I'm just grabbing the sandbox for my app, and I'm saying I want you to find staff.plist. So now I've just loaded everything into my dictionary. So now, just like any other dictionary, I can iterate through its values. So I know that each of the values inside of this array is going to be a string. So I just went ahead and created a string iterator here. And you'll remember that if we look in the plist, that my first key here is called staff. So I can't just store a flat array, because that's not a key value pair. With every value, like this array, there needs to be associated a key. So this top level key here, staff, is the container for this array. So to access that container, I can just use the dictionary method value for key, and that's going to pull back the array that's associated with the key staff. So now I'm going to start iterating through that. And what I'm doing here is now creating a UI not from Interface Builder, but from Xcode and Objective-C code. So just like we're used to typing something like UI label star label and then putting an IB outlet in front of it and connecting it. So that works well if you've already created that inside an Interface Builder. But what we're doing now is we're actually creating these objects on the fly. So when we saw the ATM example in the tic-tac-toe, we had to drag and drop 9 different boxes and then change all their tags manually, which was kind of annoying. So what we're doing here instead is creating a more dynamic user interface here. So for every string, I want to somehow display it on the screen. So that seems like a good job for a label, whose job is to just display text. So I'm going to alloc a new label. And the argument here to this init method is going to be where on the device screen I want the label to be displayed. So with every label is effectively associated this box. And that box has 4 corners, each of which has a specified coordinate. So in Objective-C terms, this is called a frame. So the frame data type is a CGRect, which stands for core graphics rectangle. And so the way of just defining a rectangle is with this actual C function that just takes as its arguments the corners of the rectangle. So I have the coordinates of the top left and the coordinates of the bottom right, so x, y, x, y. And so basically by iterating, by changing the value of this variable here called y, with every iteration, I'm basically displaying the labels on top of each other. So I'll have some vertical list of labels, which we'll see later we can do even better with table views. So now once I create this label, and I've defined each one to have a different set of coordinates on the screen, so they're not all on top of each other, I can say I want to add it as a subview. So where did this self.view come from? Well, this view property, if we come into the nib file, is equivalent to this view object. So every view controller has associated with it this generic UI view. And this UI view is going to act as a container for all elements that are put inside of the view controller. So I can't just say self add subview, because when I say self, I'm referring to the controller. I want to actually now access the view part of the view controller by saying self.view. So when I add the subview, this is where I'm actually adding the component to the device's screen. So you'll notice here that in this case, I don't really care about each label. Once I add it, I'm kind of done with it. But if I wanted to do something like give each label a tag or even store them in some array, I could very easily modify each label after I've added it. So no need to make any connections here. If I create it in code, I can then access it in code. So if I run this, this should be pretty straightforward. We'll just take that plist and display it as a list of names on my app. Any questions on how I got from that plist file to this beautiful app? Yeah? So the add subview, this call here, was what's actually adding the label to the view. So when I just create a label, all I've done is put some object in memory. Right? It's not anywhere on the screen. The device has no idea what to do with it. It's just floating around in memory somewhere. So it's not until I call this add subview that the object is actually added to the device's screen and the user can see it. Other questions? So takeaways here are just this few lines here. Technically, really only one. Can you get from a plist file to a dictionary containing everything for you? And you'll access those key value pairs using pretty much just this value for key, which gets the value for a key. So the problem spec talks a lot about equivalence classes. So if you Google equivalence classes and you'll see the Wikipedia article, you'll see something like that, which hopefully makes enough sense to you, and we can just finish now. Last year, we've done this project before, and we had a student who asked, I can't find the documentation for NS equivalence class. Sadly, that doesn't exist yet. But an equivalence class is really just a really fancy term for a set of objects. So everything in an equivalence class has to share some property. So in this case, the property that every element in a given equivalence class is sharing is that there is a letter at the same location. So the order of the letters matters. So in the case we looked at before, that first example, here are two different equivalence classes. The blank blank n class, which consists of all the words that have an n at the third location, and the n blank blank class, which is, although just has one n, is a different equivalence class because the n is in a different position. So when you're coding this project up, don't forget about the blank 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 equivalence class, or effectively the class that represents saying, no, this letter is not found. And oftentimes that will be among the largest classes. So is everyone clear on the jargon there? So an equivalence class is just a group, in this case, a group of possible responses to the user in which all of the words inside of that group have the letter in question at the same position. So when the user guesses something, we want to somehow take our words and group them into equivalence classes. So how do we define the collection of words in an equivalence class? So this is kind of up to you and your implementation. But we can utilize now these already built-in Objective-C collection classes. So we could define the words in an equivalence class as a dictionary, as an array, as a set. Those are pretty much your three main choices. You could come up with something else. But there's no use in implementing your own linked list or implementing your own hash table here, because this is something that's already built into Objective-C. So defining how you collect all of the words in a class, you should just use some built-in container. And so here's some pseudocode for your algorithm. So for every word that's remaining in your set of possible words, you want to do two things. You want to first determine the equivalence class that that word belongs in. So somehow look at what the word looks like and determine its equivalence class. So once you've determined the equivalence class, you want to add it to the collection of words contained in that equivalence class. So those could be the same step, the same line of code. There could be multiple steps. So once you've gone through every single word, you now want to make a determination as to what the largest equivalence class is. So again, how you do that depends on what container you're using for all of the words. But once you've determined the largest class, you now want to remove all of the words in the complement of that equivalence class. When that just means every word that is not in that equivalence class means that you cannot use that ever again. Because by using an equivalence class, or using it as your response to the user, you've effectively committed to some fact about the word. So that means that any word that breaks that fact, or that doesn't fit in the equivalence class, can no longer be used. Right? You can't say the first letter is an A, and then at the end of the game say, oh, the word I was thinking of was bad. Because that just doesn't make sense. And bad would not be in the same equivalence class as the equivalence class of words that have A as the first letter. So that shouldn't ever be something that your app does. And finally, you want to somehow update the UI. So again, using this MVC approach, we have a model. And the model is going to define our equivalence classes, what words are in the equivalence classes, our entire set of equivalence classes. And our view is going to be the actual UI. So there are going to be two steps to this process. And forgetting one is either going to make a really boring game or a game that doesn't work. So each equivalence class itself contains a set of words. But we also have a set of equivalence classes. So in order to determine which one is the largest, we somehow need to keep track of all our equivalence classes. So we can't just add a word to something and then forget about it, because then we have no idea which of these is the largest. So we need to make sure that we're keeping track of every equivalence class that we generate. And also make sure that you're not adding a word to an equivalence class that doesn't exist or hasn't been initialized yet. Something like initializing a dictionary or an array is really easy to forget and I can save you hours of headbanging by saying to make sure you init and alloc all of your arrays and dictionaries. So in the case of a tie, remember, you need to break the ties pseudo-randomly. So we'll look at the Objective-C ways for generating random numbers, which are basically the C ways for generating random numbers. So let's talk a little bit about design. So choice of data structure here is really important. So some basic facts about data structure performance. Iterating through a long list is going to be very slow because you need to look at every single element. You need to maybe do something with it and move on to the next one. Indexing into an array or a dictionary is going to be very fast. Right? To get the 100th element of an array is much faster than to iterate through 100 elements of a linked list. So even though you're using some built-in collections like array or dictionary or set, keep in mind that just calling a method on one of these collections is not guaranteed to be constant time. Right? Think about what the method is actually doing. Right? The classic example being strlen. A lot of people just see, oh, I strlen, that's just going to be instant. I'm going to get the link to the word. When in reality, in order for that to work, you need to actually look at every single letter. And that's not clear by just calling that one line of code. So related to time consumption is also space consumption. So as we said, words.plist is pretty big. So doing something like loading the entire dictionary into memory isn't immediately the best idea, right? If we know that our word only has 3 letters, why should we bother loading some of the largest words in our dictionary into memory? That's kind of a waste. And similarly, a waste would be keeping around words that we don't care about. So if we know that we've eliminated almost all of the words in our set because the user has made a lot of guesses, there's no point in leaving around all the words we know can't exist. And because you're working with a device that has very little RAM, it's going to be a total deal breaker here. Because the device needs to be doing other things. You might have other apps running, and you can't just take up all the RAM you want because your game is so amazing. So keep that in mind as you're designing this. What might be a useful exercise is if you can, try to run this on an actual device. So when you run it on the simulator is using your super amazing MacBook's processor. And that Core i7 is really fast. Now, so iterating through the dictionary could be instant operation or maybe like a half a second delay. When you actually load it on the device, you're obviously using the device's processor. And now an app that worked instantly on your computer could actually take 30 seconds on the actual device because the processing gap is that big. So that might be something you might want to do in order to test how efficient your design really is. So while we're talking about performance, we should mention one of my favorite software design quotes by the man who wrote LaTeX, my other favorite thing ever. It is important to consider performance in your app, but don't spend all of your time on solely performance. Right? When you produce an application, I don't want to see like system calls and like crazy assembly in your Objective-C app, because that's just nuts. And similarly, I don't want to see this mess of code that works really fast, but you at this point don't even understand what it does. So you need to strike a balance between a really well-performing app, something that doesn't take a lot of time and doesn't take a lot of space, and an app whose code is elegant, it's easily readable, it's divided into relevant classes, and things like that. So as you're developing, don't focus too much on either one of these, but try to get a balance between good design performance-wise and good design I'm going to have to read your code-wise. So questions on equivalence class stuff? OK. So the spec mentions a lot about protocols. And right now, protocols seem a little abstract, and like, why would you even bother? So the syntax. So first, let's just take a look at the syntax for a protocol. So to declare one, it's really easy. Just say @protocol. You're going to give the protocol a name. Style conventions say that this should be following the same naming conventions as a class, which means camel-cased, capital letter for the first letter. Then inside of there, you're just going to define all of the methods that someone using this protocol can implement. End it with that end. So the reason for this being that multiple classes can implement the same protocol. So in this utility app, the point of that first protocol, the flip-side view controller delegate thing, is a little pointless because there's only one thing using it, so it's like, why bother? But in this case, we can have multiple classes using the same protocol. And again, this is different from extending the class because the protocol does not define what these methods do. It simply declares that this exists. Whereas if you had some class you were extending, that class could hypothetically define what each of these methods does, and then you could either extend them or override them. A protocol, on the other hand, is like an interface in many other languages, and it just says that this method exists. But saying that this method exists and that this class implements this method is actually a really big deal as far as our design is concerned, because we're now guaranteeing that an object can respond to this message. So let's motivate this in the context of evil Hangman. So you have two strategies. There's a good strategy and an evil strategy. So as input, the good strategy is going to take some letter. And as output, the good strategy is going to say an answer to the user, like as far as what letters are used. The evil strategy is going to do exactly the same thing. It has the same input, and it has the same output. So that suggests that there's no reason why both the good object and the evil object can't respond to the same message, something like play or use word or guess letter or something like that. So if we don't use protocols, we have to do weird things like, is this the good strategy? Call the good message. Is this the evil strategy? Call the evil message. And that's really awkward, because if we had a bunch of strategies, we're going to have some big if or some big case switch. Using a protocol is going to save us a lot of code. We can just say, I have some strategy object. I don't know if it's good or evil, but because it's a strategy object, and because I've implemented this protocol, I know that I can pass it the play message or call the play method on it. Because by implementing the protocol, that has to exist. And that, in a typed language like Objective-C, is a really big deal. So let's create a new project here. It doesn't matter what the view is, so we'll just call it example. Create it. So I want here an app that, unfortunately, I'm not going to write Evil Hangman for you. But in this case, I'm going to write an app that grades all of your Evil Hangman implementations. So our core staff has both TFs and CAs, and both TFs and CAs need to be able to grade. So all right, so let's create first some object representing a TF. So if I right-click here and say New File, I'm going to use an Objective-C class. The class name is just going to be TF. Now I'm saying it's a subclass of NSObject, not of a view controller, because this is effectively just a model, some container for data. I'm going to say next, and we'll just create it inside of my project. OK, so there's my TF. I don't really need to change this much. But because I'm a really good software designer, the first thing I want to do is define some protocol. And the protocol is going to define all of the things that a grader can do. So inside, now I'm just inside of my viewController.h. I'm going to say at protocol, nice autocomplete here. And I want to say this is the grader delegate. So just like the UI text field delegate, this defines a list of things that a grader can do. So let's just say that a grader can not type grade. So this grade method is not going to take any arguments, and it's just going to return a numerical score. So anyone I want grading p-sets, I need to make sure that they can actually grade the p-set and give a score to it. So here's my TF. I want this TF now to use this grader delegate, because the TF can grade things. So I can't just immediately say grader delegate, because the compiler doesn't even know what that is. So I define it in this case inside of viewController.h. So I'm just going to import that. So now the compiler knows all of the protocols that I've defined. So I'm just extending NSObject here. I'm not changing that. But now I'm implementing grader delegate. Again, just that list containing one method that says grade. So there's no need for me here to say something like int grade or something, because it's already defined for me in the protocol. So this is implicitly there, and I shouldn't duplicate that. So now if we come over to here, you'll see immediately that I have this warning. If I click the arrow, we see it's an incomplete implementation. Why? I haven't defined anything in my .h file. Because I'm now implementing this protocol, the compiler recognizes I did not provide a definition for that grade method. And in order for me to implement that protocol, I need to give that grade method some definition. So let's do that. So if I start typing int grade here, you see it's auto-completed for me, because Xcode's the best. And so now I just want to return something. So being an amazing TF, the way I grade p-sets is I just assign each of them a random number. So to do that in Objective-C, we can do is we can import standard lib. So something you might have seen if you've used C before. But inside of standard lib, there's this cool function called arc4random. And it just uses this cool random number generator algorithm that doesn't require you to say sran time null, which is kind of awkward to look at. So I'm just going to return arc4random, but I also want to establish some upper bound on your grade. So this is going to return a random number between 0 and the maximum, so like some defined maximum. So by modding it by 5, I ensure that none of my scores exceeds 5, because that would just be an invalid score. So So that makes sense, everyone, how that works? So there's your random number in one line, just arc4 random. It's inside of standard lib. So we build this, and we're good to go. OK. So now I'm not actually going to do anything with the user interface here. But what I want to do is define a couple of TFs. So to access that object, I first need to import the file. So I'm going to say import tf.h. That's fine. So I'm going to say, all right, so Tommy's a TF. So he's going to be alect and initted. And Rob is TF. And he's going to be alect and initted. Make sense? Just creating two TF objects there. So now let's put these two objects inside of an array that defines the staff members. So if I say nsArray staffers, I can say nsArray. And then I want to actually add these two objects to the array. I can say array with objects down here. And this just takes a comma-separated list of the things in my array. So Tommy's in staffers, and Rob is in staffers. And by having this last argument here be nil, that just tells this method to stop adding things to the array. All right. So now I have my staffers. So now I can iterate through this. So if I say, I know that everything in my staffers is a TF. So let's just say for TF in staffers, I can say TF grade. And that's going to make sense because everything's a TF. All TFs can grade. So if I just nslog the result by saying something like grade, it's an integer. And I'll spell this right. So this is now just going to output effectively two random numbers, which I promise all of your grades are not. So nothing's going to happen on the user interface. But down here, you'll see I've just output two random numbers. So now, let's throw something else into the mix. Let's say that I want to have a CA, or a course assistant. That's a little bit different than a TF. But in this case, let's just say my CA can also handle grading psets. So all right, so let's just create a new class here. So new file, regular class. Now it's a CA, saved in the same place. OK. So now I want to add a CA to my staff. So if I add so first, need to import it. ca.h. So let's just call the CA Bob. And let's add him to our staffers. OK. So now we have a little bit of a problem. Now our array of staffers contains two things. It contains the CA, and it contains the TF. So I can't just say something like for TF in staffers, because that doesn't make sense, because not everything is a TF. So let's just say, well, how about this generic ID thing? So this ID is effectively a void pointer. It doesn't really have a type, but it is some object of some type. Well, this isn't quite it there either, because the ID, this generic object, there's no guarantee that it responds to this grade message. So what we need to do here is, without special casing anything, somehow have both of these types of objects grade. So to do that, what I'm going to do is, inside of my CA object here, again, I'm going to import the definition of this protocol, and I'm going to use it. So now both the TF and the CA implement the grader protocol. So that means that I have to provide a definition here for grade. And CAs are really mean, and they're just going to give you a 1. So this is a different definition of grade, because this is now a different class. However, because I now know that both a TF and a CA implement the grader delegate, I know that I can pass the message grade, and it's going to behave just as I expect. So now, rather than just saying ID, some generic object, I want to say, well, I want some generic object that implements a grader delegate. And so this syntax here just says that whatever this is, it is something that implements the grader delegate. And because I know that everything in this collection implements this delegate, I know that I can safely pass it this grade message, because it was defined in the protocol. So let's just change TF to staff, since they're not all TFs anymore. And so now you can see, if I run it, I now have, well, that's an unfortunate sequence of random numbers. But now you can see that all three of these objects, although they are different types, are all doing the same thing inside of this loop. So I didn't need to special case anything like is kind of class TF or is kind of class CA. Because I know that they're both implementing this same protocol, I can safely say grade here. So does that make sense to everybody? So similarly, your strategy for evil Hangman is you're going to have a similar setup, right? Here we have TFs and CAs. Now you have some good strategy and some evil strategy. And what you want to do is somehow take some input and pass it to one of these strategies. And you don't know which one the user currently has selected. It could be a good object or it could be an evil object. So because both of those classes are implementing some protocol that you define that defines what it takes in order to respond to the user, you know that you can safely pass this message to anything that implements the protocol you define without having to worry about special casing anything. So clear on a design perspective why these are really helpful? OK. So another required feature of the game is that high scores need to be displayed using a modal. So this is going to require you to create a new view controller. So we've only created classes here. But if I wanted to create a new view controller, I'm going to go through much of the same process. I'm going to double tap this, say new file. But now, instead of simply subclassing NSObject, I want to instead subclass the UI view controller. Not the UI view and not the UI table view controller. Those are other things. But the UI view controller, and then if I check this box off, it's also going to create a corresponding nib, or a UI file for me. So then when I click next, I'll just call this class something. Now when I create this, I have down here a .h, a .m, and a nib file. So just make sure that you're subclassing the appropriate thing. So your strategy shouldn't be a subclass of a view controller or a view, because that's not what it is. It should just be a subclass of an object. But if you want to be able to get this nib for you, this nib generated for you, and to actually present it to the user, you need to make sure that you're subclassing the UI view controller. So to transition between the views, you're going to do the same thing that the utility app does. The utility app template does. You're going to want to alloc and init with nib named the view controller that you want to display. So in this case, I would alloc my something controller when you want to say your history view controller. You want to make sure you pass in the file name of that nib without the .xib extension. And then, after that object has been instantiated and you've said which UI file to use, then you can call that present modal view controller, and you're off and running. So you probably want to define, follow a similar path as the template code does. So the template code defines this flip side view controller delegate. And using that, you can get back to the main view, right? So if the user presses something on the flip side, it's going to go back to the main view controller. You probably want to do something similar with your history view controller, or else the user is going to have no way to get back from that history view to their settings or their game. So definitely use that as your approach, the code that's already written for you in the templates. So finally, something you'll have to do in your app is store settings. So when I adjust the length of the word or the strategy that I'm using, if I were to force quit the app and restart my device, it should remember the settings that I last used. So I don't have to switch to evil mode every time I turn on the app. So the class that's responsible for doing this in Objective-C is called the NSUserDefaults. And likeplists, all this does is store key value pairs. So you don't need to worry about implementing a database, so don't bother Googling core data or SQLite 3 or anything like that. This is basically handles all of that for you, just persisting keys and values. So like that NSBundle singleton, we also have an NSUserDefault singleton. So just a single instance of this class that can be accessed anywhere in your app. So by saying standard user defaults, that's getting back this singleton object. Now on the singleton object, I can pass messages that either set the contents of a key, so I can save any object. Unlike local storage, we're not restricted to just strings. We can go ahead and just persist an array or an integer or whatever you want. And then you give it a string key, and that will just persist. If you want to get the value that's associated with the key, you can say object for key, and that's just going to give you back whatever it is you saved, no JSON.parse or anything like that. Know that if you want to be less generic than an object, you can also say things like string for key or number for key. And there are a number of convenience methods that are built in, so you don't have to cast things. So now if you want to remove something, just remove object for key, and then it's no longer going to be persisted. And finally, the synchronize message is what's actually going to commit your changes immediately. So what's going to happen is if you change something in NS user defaults, Apple says that, well, eventually I'm going to persist that to disk. But if I don't do that immediately, like, oh well. By saying synchronize, that's going to say right this second, write these changes to disk. That's probably a good idea to use when you're doing something like changing from the settings back to the game view. Because if you were to change the settings and then really quickly kill the app, if iOS hasn't gotten a chance to write out the settings to disk yet, you're just going to lose them. So by saying synchronize, that guarantees that everything is written right away. So again, you can read and write anything that's savable in a plist, any of these generic data types, and these convenience methods that prevent you from having to cast from a generic NS object to the data type in question exist. So let's just take a look at an example here. So my app here is really simple. I have a text field and I have a button. And I'm going to type some text into some text field, and it's going to save it. So the next time if I quit my app or restart my device, next time I load my app up, I'm going to pull the text that was stored. So let's take a look at how I've done this. So everything here just inside of my view did load. So the first thing I'm doing here is registering some default values. So in your Project Zero, if you're using local storage, you may have had to special case if you're trying to pull data from local storage, but there's nothing there. So you probably said something like if local storage recent is null, then just like make it an empty array. That's something we also have to do in Objective-C. Because if there are no default values, they're just not going to be there, and our code is going to be in trouble. So if we want to say that if I fresh install of the app, I want to say, well, we're going to default to the evil strategy with 5 words, 5 letters in a word. That's effectively our default values, or the values that are there if the user hasn't saved anything to NS user defaults. So luckily, that's really easy. So what we're first going to do is just define some dictionary. Again, a dictionary because we're using key-value pairs, where a value can be an array, or can be a dictionary of whatever. And we're going to say that this key here, text, which is the key I'm going to be using to persist the text, I want its default value to be just the empty string. So now I'm going to retrieve my user defaults. Again, this is just going to give me back this singleton object. And I'm going to register these default values. So I'm going to say, if there's nothing there, these are the values that I want you to return for the keys if I try to access them and there's nothing there. So keep in mind the spec requires you to do this. You could just as easily special case everywhere, say if it's nil, return empty string. If it's empty string, do this. But this is much, much, much better in terms of design because you can kind of centralize all your default values here, very easily change them, and not have to worry about special casing pulling nil values. So the spec does require you to say register defaults. And to answer the FAQ, yes, you could do this without register defaults, but it's going to be kind of a mess of code as you get more complicated. So now, when I first open the app, so when this view did load is fired, I want to load in whatever was stored in my key value pairs. So whatever is previously in this text field, this text value is now going to be stored into my text field. So again, if there's nothing there, I don't have to worry about nil or the null awkward case. It's just going to be empty string because I've registered that as the default. So now down here, when I press the button, and this is an IB action that I've created and connected already, I want to actually persist the value that is in the text field to the NS user defaults, or to the disk. So again, I need to first retrieve this singleton object. So once I have that singleton, I'm going to set an object for a key. So value key rather than key value. But I'm just saying that now, when I try to use this key text, I want to save the object that is the string currently typed into the text field. So now I'm also saying synchronize so that everything is written immediately. And finally, just removing the keyboard again. So we looked at become first responder earlier. Now resign first responder is the opposite, or sending the blur message, saying I no longer want the text field to be focused and the keyboard will disappear. So when we run this, So right now I don't have anything, but if I type in something like CS164, I click Save, you'll see the keyboard goes away because I've resigned it. Now if I quit it and run it again, you can see that this text was preloaded. So same thing, not only do I have to could I restart the simulator, I could also quit out of here. If you haven't used an iPhone before, to quit a running app, you're going to double tap the home screen, hold on that, and then you can just quit the app that way, which will also crash my debugger. But that's another way of testing that. So questions on NS user defaults? All right, so any questions at all on the project as a whole, ways to go about implementing this, specifics of the algorithm or anything like that? Yeah? Oh, sure. So I was just showing, in this previous example, the difference between creating a generic object and creating an actual view controller. So it's not actually this one? Yeah, so this actually isn't used anywhere in the app. But just keep in mind that when you actually want to create a view controller, as opposed to just some generic object, which we've seen a lot of, you just want to make sure that you're still clicking on Objective-C class. There's nothing fancy there. But you're subclassing UI view controller, and you're checking off this text box. Other questions? All right, then there will be office hours tonight from 6 to 8 for Project 1, which is due this Friday. And then good luck getting started on Project 2.